Now in this question, see, suppose there is a clock. Now in each of the position of the hour, we are putting a charge, that is 12 coulomb, 1 coulomb, 2 coulomb, 3, 4, 5, 6, 7, 8, 9, 10, 11. And at the center there is a 1 coulomb. So the question is, what will be the net electric field at the center? Net electric field, because field is equal to, we know that the force experienced by unit positive charge. So what is the net electric field at the 1 coulomb? This is the question. So now how to do this question? See what will happen actually. This 1 coulomb, this 12 coulomb, let us start from this one. This 12 coulomb will give a force in the downward direction, and 6 coulomb will give a force on upward direction. So therefore the net force becomes 6 coulomb. Okay, because 12 coulomb minus 6 coulomb, 12 coulomb giving downward, 6 coulomb giving upward. So therefore cancel out 12 minus 6. So ultimately it becomes a force, 6 coulomb force in the downward direction. Similarly, see, this is 1 coulomb and vertically opposite direction 7 coulomb. So 1 coulomb will repel in this direction, 7 coulomb will repel in this direction. So again the net force becomes due to the 6 coulomb. So that will be in this direction. Similarly, this is 2 coulomb and 8 coulomb. So again this 2 coulomb will give a force in this direction, 8 coulomb will give a force in this direction. So 2 minus 8, again it is the force due to the 6 coulomb in this direction. Similarly, see, this is 3 coulomb and 9 coulomb. Again 3 coulomb will give a force in this direction, 9 coulomb will give a force in this direction. So again the net force will be due to the 6 coulomb. Similarly, this is 4 and 10, again it will be force due to 6 coulomb, and 5 and 11, again this will be the force due to 6 coulomb. So therefore all the forces are due to 6 coulomb, the resultant force, and the angles are basically, see, this total is 90. So therefore if you equally divide into 3 parts, so each part will be 30. So therefore this angle is 30 and this angle will be 30 plus 30, that is 60. Similarly this angle will be 30 and this angle will be 60. And this is obviously 90. So therefore what we can do, this AFC can be split up into 2 components. One will be, this F will be in this direction, that is F cos 60, and this is F sin 60. So F sin 60 will be upward, and in this direction F cos 60 will be there. Similarly, this F also has a component F cos 30 in this direction, and in the upward direction F sin 30. F sin 30. Similarly, in the downward direction, this F also in this direction F cos 30, and in the downward direction F sin 30. Similarly, this F also in this direction F cos 60, in this direction F cos 60, and in the downward direction F sin 60. So therefore what will happen, this sin 60 and sin 30 F and this sin 30 and sin 60 actually cancel out each other. So the net force downward direction is F. That means along Y the net force is actually F. Similarly, now what is the net force along X? So the net force along X becomes, one F is there already, that is F plus, now F cos 30 due to this one, F cos 30 due to downward. So 2F cos 30 plus F cos 60 due to this one, F cos 60 due to this one. So it will be 2F cos 60. So therefore ultimately it will be F plus 2F. Now cos 30 is actually root 3 by 2 and 2F cos 60 will be half. So therefore it will be ultimately F plus F, that is 2F plus F root 3. So therefore if you take out this F, it will be 2 plus root 3, that is the Fx net. So now F, so Fx and Fy we get. So now the resultant force Fr can be calculated root over Fx square plus Fy square, because Fx and Fy, the angle is 90 degree, so a square plus b square plus 2ab cos theta, so 2ab cos 90, that is actually, so cos 90 is 0, I am not writing that part. So therefore it can be written as equal to root over Fx square, that means it will be F square 2 plus root 3 whole square plus Fy square, that is F square. So therefore what we can do, we can take out this f square common, so f beri jabe, so it will be 2 plus root 3 square plus 1, that is actually the fr. And this f value we can also calculate, f equal to what, it will be k, all the forces are due to 6 coulomb, as I said, that 1 minus 7, 2 minus 8, 3 minus 9, 5 minus 11, all are 6. So it will be k into 6 divided by, now the distance, the radius of the clock is, suppose it is given 30 centimeter radius of the clock. So therefore it will be 0.3 square. Okay, so we can easily calculate this value of f. K value we all know, 9 into 10 to the power 9 into 6 divided by 0.3 into 0.3. So therefore if you remove this to point, it will be 100. So 3 3s are 9, 9 cancel out. So it will be 6 into 10 to the power 11. That is the Newton. So therefore if you put this value here and if you calculate, so finally the answer will be 23.2 into 10 to the power 11. So final answer will be 23.2 into 10 to the power 11 Newton.